if you are going to solve this problem, you should solve the valid Sudoku first. Yeah, after you solve the valid Sudoku, you have a basic idea of about what Sudoku is and how you are going to use the set to solve the problem. But for this one, we are going to use backtracking because it's just a board. Yeah, the length is 9 times 9. Yeah, it is not a digit inside, it is a dot. So we're going to use the backtracking to track one by one, and it is guaranteed to has only one solution. So yeah, we are safe to use backtracking to get the solution. So basically it will be like this. So we have a few numbers and we're gonna check if yeah, we're gonna first put the dot. So put the dot into a queue. So inside the queue will be the R and C. Yeah, if this R is 0, C equals to 2. So we put the tuples R and C inside the queue. And while backtracking, we're gonna check. Yeah, we're gonna put this R and C, take it out and try numbers from 1 to 9, because for this one we will try 1 to 9, for example. Yeah, it's basically the same as when we are solving the Sudoku, we need to input the numbers inside. If you are interested in the game, I think it's basically also the same. You're gonna check, oh, here we can put 1 inside. Yeah, we can put 1 inside here, and then we go to here. We also going to check because we've already put the 1 inside. Maybe we can put a 2 here, because here row and column there's nothing inside, and for the square it's also not inside. And here maybe we can put a 4 inside, because here is 1 2 3, and here is 5, and here is 4, and there's nothing for here and in square. What about here? Maybe 6. We cannot put 6 because 6 has already been there. 7 has already been here. And what about yeah, so what about 8? Yeah, we can put 8 here. Yeah, and maybe next we can put 9. I'm pretty sure I made a mistake because there should be, yeah, the 6 should not be here because this is inside. So it means it's not a valid solution. So here we put 6, not. So we have to go backtracking. Yeah, this is why we will go backtracking to check. Yeah. Now let me go to the code editor to realize this idea of the backtracking for solving the Sudoku. Yeah. So similarly, like valid Sudoku, I will define some variables. So for row, column, and square, it will always be default text, and inside it will be set. Yeah. So we will prepare some set, and inside it will still be the set. So this is similarly like valid Sudoku, and we gonna also prepare a queue. So this queue will be the queue, and the RC should be the same. The length of the board, and length of the board 0. Yeah. Then we're gonna use the for loop to check for R in range R, for C in range C, and we're gonna check if board RC not equal to the dot. Why we gonna check like this? Because we wanted to, if it is not the dot, it means it's numbers. We want to put the numbers inside the set. Yeah. So though R should add this board RC. Yeah. to add these numbers inside. Similarly, column C should add the board, add this number. And also for squares, we need to be careful. It should be R divided by 3 and C divided by 3. I've already explained why we're gonna use this, because this can represent the conditions, yeah, for this R divided by 3, C divided by 3, it means a square, yeah. So it's gonna add the board. So this means the numbers will be added into the different set, row set, column set, and square set. If it is a dot, we're gonna to put them into the queue. So the queue will be a tuple. The R and C should be okay. It means all the different positions. Yeah, so here means we put the different positions into the queue. So the position, according to the positions, we know, because we will try to put the numbers in the different positions. Yeah, so this is why we need to put the R and C into the queue. Yeah. After that, we're gonna define our backtracking function. So the backtrack should be the function, and what I'm gonna return is also the backtrack, because it will be in place. We don't need to return a board. Yeah. So for the first step, we're gonna check if not queued. Yeah, if we used everything inside of the queue, it is okay. We can return true. Yeah. Otherwise, we're gonna to take this R and C outside of take it out, so it should be called 0. So from the left side, we take out this R and C, the x-axis and y-axis. So here is R and C, row and column. Yeah. When we take out the row and column, let me explain. When we take out, for example, this is a code inside. We take out this one. We're gonna try the numbers from 1 to 9. Yeah, and how we're gonna try? We're gonna check if this number is in the first row or in the third column, or this number is inside this first square. Yeah, we're gonna check like that. So R and C equals to this queue, and we're gonna also define a number. So this number will be 1 to 9. So it will be list. It will be set. Yeah. For saving the time, we will always use a set. Now let me, put the list and strings 1, 2, 3, 4 until 9. Yeah. And then we are going to use the numbers inside. So for I in number, we're gonna try. Yeah. So how we are going to try? We have to check the conditions. Yeah. So if I not in the set, so the set will be row R union. I think we call it union. Yeah, and the column C and the union square should be R divided by 3 and C divided by 3. So this means we're gonna check if this number I is not inside the column row set and the square set. If it is not inside, we can put something to add. So for the row R should add this number, and the column C should also add this number, and square. Let me check square r divided 3 and c divided 3. Why? Because here this r and c is q append. It can be 8, yeah, the maximum. So this is why we're gonna use divided by 3 and this number I, yeah. And we are also going to put the I inside the board because we're gonna return the board, yeah. So the board RC should equal to this number. So what is the number is I. And if everything is okay, finally we're gonna pop this RC out of the queue. So should use the queue dot pop left. Yeah, we're gonna pop it. Yeah. And then we're gonna check the backtracking. If the backtracking is always true, we can finish that backtracking. It means for this number, if it's not inside, we try, and for another number, we also, yeah, for I in this number. Yeah, it means we checked all the numbers. I believe it should be okay. So yeah, because we are using the queue. Yeah, so this queue is we're taking out. This is for one case we take out of the queue. Yeah, this is also useful for checking or analyze the time complexity. So the length of the queue here is the number we need to try. Yeah, so I will analyze the time complexity later, but that should be difficult to analyze. I'll just finish the function. Yeah, because this one we just use the queue to check. If it is not queue, we'll return true. So if we can backtrack all the cases, we can return a true. Else we just need to set backtracking. Yeah, else we're gonna backtrack. So what's inside the backtrack is here. Else we just recover everything. We just copy everything from here. Yeah, now let me just here because we're gonna recover. How to recover? We need to discard because we added. After added, we need to discard everything inside. Yeah, here we need to set it to a dot, and this should be a pad to the left because it's pop from the left. You pop from the left and then you append to the left because you will always use the first number, first R and C inside the queue. Yeah, so here need to use a pad left. And this is okay. If we didn't find it, we're gonna return a false. So why the false should be here? I mean outside the for loop. So here, because we have to try each of the numbers. If we didn't find, we can return a false. For example, this is from here. Imagine from this point, yeah, but we don't have the case, but imagine we have a case. We checked everything. We checked everything like, yeah, like this point. We tried number 1, not possible, 2 until 9, not possible. We're gonna return a false. But of course, from here, it will not gonna return false. But maybe somewhere, some places, when it goes to here, yeah, we didn't find and we return false. But that is not the end of the backtracking. The backtracking is still going. How it will go in? Because here return false, we just set it back. Before, maybe we use a number like maybe 9 because here is a 9. It's not possible, and we set yeah, not 9. Let me give another example. Maybe 1. Yeah, maybe 1 is not possible. We're gonna try 2, not possible. Maybe we find a number, maybe 6. Yeah, put the 6, and then it's possible we're going to return true. If we find a number 1, maybe 2, it's not possible. What we're going to do is the backtracking is not true. Yeah. How the backtrack is not true? Because here we tried everything. We're going to return false. So that means from there it will be false. So if it is false, what we're going to do is set it back. So the row will discard this r, discard this number, and here square will discard, and here will be the dot and append left. Yeah, I think that's basically the entire code. It's like 30 lines. Yeah, no less than 40 lines of code, except for these 5 lines. Yeah, maybe. Yeah, just more than 30 lines of code. Now let me run it to check if it really works, because a lot of code maybe typo or some error. Yeah. Pop left. Here I pop left didn't recover it. I needed to recover R and C. Yeah, because we pop left. What pop left is R and C. We needed to append inside the queue. Append from the left side. Yeah. Now let me submit it. Yeah, as you can see, it really works, and it beats 54% of all Python 3 submissions. But now let's calculate the time complexity. As I said, this would be difficult. Yeah, because you basically, if you put everything inside a set, it means there is also set calculations. It means the set calculations is only yeah, and for this numbers you will try 9 numbers. But what if you have a few numbers inside the square, inside the column, and inside this rows? Yeah, you never know how many. Maybe you have 2 choices for each of the empty square, and how many squares we are also not sure. Yeah, maybe there are 20 or something. We are not sure to the square of 20. But when you put more numbers inside, for example, yeah, when it goes to the last part, you're gonna just try not so many different numbers. Yeah, so this is difficult to analyze. So I'm just gonna yeah